Welcome back to the Dr. Liu VCE Physics channel. In this video, we'll be going through the 2018 physics exam, focusing on questions related to gravitation and planet motion. My explanations may not be perfect, so if any teachers, parents, or students notice any errors, please feel free to offer your feedback. The gravitational strength is inversely proportional to the square of the distance from the center of mass. Therefore, a location at a height of 2 Earth radii above the surface is at a total distance of 3 Earth radii from the center. At this distance, the gravitational strength is 1/9 of the gravitational strength at the surface. The spacecraft Juno has been put into orbit around Jupiter. The table below contains information about the planet Jupiter and the spacecraft Juno. Figure 11 shows gravitational field strength as a function of distance from the center of Jupiter. The gravitational force on the Juno spacecraft from Jupiter is the product of Juno's mass and the gravitational field strength at its location. From the graph of Jupiter's gravitational field strength versus distance, we find a value of 3 N a kilogram at a distance of 200 million meters from Jupiter's center. Therefore, the gravitational force is calculated by multiplying 3 N a kilogram by Juno's mass of 1,500 kilograms. Gravitational energy is a form of potential energy that depends on an object's position. As Juno moves from 200 million meters to 100 million meters, the change in gravitational energy is the difference between its potential energy at these two positions. Using the graph of Jupiter's gravitational field strength versus distance, we can find the values needed to calculate this change. Assuming Europa has a circular orbit, we can use Kepler's formula to calculate its orbital period. We simply need to substitute the mass of Jupiter and the radius of Europa's orbit into the formula to find the result. Some students have collected data on the orbital period t and orbital radius r of 5 of Saturn's moons. The results are shown in the table below. Assume that the moons are in circular orbits. Assuming the moons of Jupiter are in circular orbits, the relationship between their orbital period and radius follows Kepler's third law. This means that a plot of the square of the period versus the cube of the orbital radius should yield a straight line. We can then plot the data points and draw a line of best fit to demonstrate this relationship. The gradient of a straight line, which represents its slope, is calculated by the formula rise divided by run. To perform this calculation, we select a clear portion of the line to measure the vertical change rise and the corresponding horizontal change run. According to Kepler's third law, the gradient of the period squared versus radius cubed graph is inversely proportional to the mass of the central body. Since we have already calculated the gradient, we can substitute this value into the equation derived from Kepler's formula to solve for the mass of Saturn. This section focuses on gravitation and planetary motion, covering 19 marks and contributing to 14.6% of the total 130 marks. Multiple choice question, 1 mark. Question 7. The gravitational field strength is inversely proportional to the square of the distance from the center. Since the object is at a distance of 3 Earth radii from the center, the gravitational strength is 1/9 of that on the surface. Short answer question, 18 marks. Question 9. Find the gravitational field strength from the graph to calculate the gravitational force. The change in potential energy is found by calculating the area under the graph of gravitational field strength versus distance. Question 20 Part A. Use Kepler's formula to calculate Europa's orbital period, using the mass of Jupiter and the radius of Europa's orbit. Part B. Plotting the square of the period against the cube of the radius for Saturn's moons should result in a straight line, confirming Kepler's third law. Parts C and D. The gradient of the straight line from the graph is used to solve for the mass of Saturn. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.